All right, this video is for the Constructions and Conjectures Bisectors notes. It's lesson 4.4. So we're going to look at angle bisectors in a triangle, angle bisectors in a linear pair, and then perpendicular bisectors. This is a lot of like proof work is what this comes out to, so that's why we're doing it together. Okay, so given triangle ABC, bisect ACB, so bisect this angle to create angles ACD and BCD. Then bisect, we're going to bisect those. So let's bisect angle C, this top angle here, first. Okay. Turn mine upside down because it's easier. So if I want to bisect this top angle, I'm going to mark with the compass an arc that goes all the way across the two adjacent sides. And then those intersections are what I'm going to use next. So I put the point on those intersections and I make two more arcs that should cross. And then where they cross, that's the connect the dot points. And so if I connect that with the angle I bisected, and I'm going to stop at the edge of the triangle. So I'll let you get that part done and then we'll go from there. All right, so we bisected it to create two more angles, ACD and BCD. So AC, that means this point right here is D. And then BCD, those are the two angles that I created in there. These two little openings. Then we're going to bisect ACD. So this little half piece that we made, we're going to bisect that little half piece now. So it's this one that we're doing right here. So change your compass measure from whatever you did the first time. Otherwise, you'll start overlapping. So from C, I'm going to make an arc across that new line that I made, and then side AC. And it's these 2 points, this intersection and this intersection. I don't need these arc marks anymore. I've already used all of those. Okay, so it's those two new intersections that we just made. And then you're going to take your compass again on those points and make two new arcs, and you need them to cross. So see, I almost didn't make that one long enough. And I'm going to put the point there, but when I play connect the dots here, from C to that point, I'm going to stop at the edge of the triangle. So I'm going to line my ruler up with that point, even though it's outside. But I'm only going to go from C to the edge of the triangle. And then that's going to create ACE. AC. So that means that point where we stopped, that's going to be E. And then the conjectures are just what happens. What happened when we started splitting up this angle, splitting up this triangle. So those two new angles that we created, angle ACD and angle BCD, so that was this one here and then this one here. They're congruent, they're the same size. So if I split an angle perfectly in half, the two halves are going to be equal. When I split that half, I made two more angles. Those angles are also going to be equal to each other or congruent to each other. So angle ACE, so that's this little piece right here, is going to be congruent to that other little half piece, which is DCE. ECD, it's the same as long as the vertex is in the center. Angle DCE. So when we split something in half, so think about it, if I split, I've got 10 calculators and I put them in 2 equal groups, right? What math would I do to put them back together? Do what? Okay, so I have 10 calculators, right? 2 groups. How many would be in each group? 5 and 5. Okay, so what would you multiply that by? Multiply it by 2. What other math could you do, though, to combine those calculators into one group? What else could you do with the numbers 5 and 5? Addition. Okay. So after everything is said and done, that first split that we made, where we did angle ACD and angle BCD, so that's the 2 big pieces. If we added those back together, we would get our original angle, angle ACB. Same with that second split. If I took these 2 little pieces and I added them together, I would get back to what I started with, which was half of that angle. So angle ACE plus angle DCE is going to equal the measure of angle ACD. It is a whole bunch of letters, but it's connect the dots. You literally, if you follow the path that those letters make, you can see what angle you're talking about. Those 2 little angles, what else are they equal to in that triangle? Not, yeah, you're right in a way, but another angle measure. These 2 added together also equal another angle in this triangle. Which one would they also be equal to? BCD. Because ACD is congruent to BCD. So if these 2 add up to make this one angle, then they also add up to make that other angle. Okay? Those are properties that you probably have not seen or talked about since 6th grade. Like if 6 plus 4 equals 10, then it's also equal to 5 plus 5. We can write math problems in all these different ways. And that's what it's kind of trying to make you look and see things that just because we don't implicitly say it, that it's equal to this, it doesn't mean that it's not the same as something else. And then these are the halves that we made. So angle ACD, that was that first half we made right here, is equal to half of our original angle. And then that second split that we made, which made ACE, so angle ACD, is equal to a fourth of the original angle measure. And so when I'm saying it's equal to a half, or it's equal to a fourth, or if we add them together it's equal, I'm meaning they measure the same thing. All of those angles would measure, that's the relationship between them and their measurements. Whew. All right, a linear pair, we talked about this for just a little bit. It's when we have a straight line and then we have another line coming off of it and it creates 2 angles, and that those 2 angles are equal to 180 because they're a straight line. So it doesn't matter how you do this, but turn that straight line into a linear pair. If it's not at the exact same angle that mine is, it's okay. That's kind of the point, is that everybody kind of has one a little bit different. So what we've done is we've created 2 angles. I have an angle here, and then I have an angle here. Okay? it says construct a bisector of each angle. So focus on your left angle first. Let's bisect this angle. Okay, so with your compass, put it on the vertex you made. We can actually do this all at once. Do you want to do it all at once, or do you want me to do them separately? Separate? Okay, so let's bisect this angle. All right, draw you an arc that goes through both legs of the angle. And then your two intersection points, here and here, use those points in your compass. So this one's going to be kind of wonky. I should have changed it. Oh, no, my intersection fell okay. I thought it was going to fall right on that first one. So what I did, I left my compass the same. You can change it. Put the point on one intersection, make you an arc. Put the point on the other intersection, make you an arc, making sure that the arcs intersect. And where they intersect, from that vertex to that point, because that's the angle we bisected, that's the bisector line. On this one that I drew, that original one, I'm going to put OG. So I remember that's the original line that I drew. Okay, and that those are the two. So this is a bisector, and then I'm going to bisect this angle now. Okay, just this piece. So I'm going to change the measurement because I don't want it to overlap. So I'm going to make it a little bit bigger. So draw an arc that goes across both legs of the angle. And those two intersection points, move your compass to those intersection points and make you arcs that'll cross. And where they cross, that intersection, back to your original vertex. Okay, that's where this whole thing started. Connect the dots to that one. So that's a bisector too. Can anybody tell what was created or the relationship between these two bisectors, just kind of eyeballing it? Can you see the relationship between these two bisectors? What happens when you bisect a linear pair? The bisectors are perpendicular to each other. So anytime that you bisect angles of a linear pair, the two bisectors are going to be perpendicular. So that's what goes here. To each other. So the angle bisectors are perpendicular to each other. All right, last one we have here, we're going to do perpendicular bisectors. So given equilateral triangle ABC, what's an equilateral triangle? All three sides are equal. All three angles are equal. Okay, they're both. Construct the perpendicular bisector of all three sides, labeling the points of intersection D, E, and F respectively. What that means, respectively, it means in the same order that it's asking you to do things. So the bisector of AB, we need to label with a D. The bisector of BC, we need to label with an E. The bisector of AC, we need to label with an F. So let's do the bisector of AB first. Okay, refresh on this. So AB, we're going to bisect this one. Set your compass to more than half. Actually, we're going to do this all in one swoop because we won't make a mess if we do it all in one swoop. Okay? Because, normally we'd set this compass and we'd do one here and we'd go to B and we'd do one and then we'd change the compass measurement. It would make an awful mess. So set your compass more than half the distance from A to B. And I want you to make an arc that's pretty big. Hopefully I did not set my compass too big. Okay. And then I want you to move to B, and I want you to do the same thing. Make you a pretty good sized arc on here. So when you make that one from B, you should have 2 intersections now. And then you're going to do the same thing from C. And pray that we get 2 intersections. Ooh, I just barely got it in. So if you get down here to this one and you go off the page, unfortunately, you got to set your compass smaller and go again. Pretty cool, nifty little pattern there. Our construction challenge for this unit, I'm going to show you how to make a perfect 5-pointed star, and then you get to decorate it. Okay, so let's just focus on AB. AB, the bisector is going to go through here. So I need, all of these should cross in the center, so I'm just going to kind of make a big point because mine are kind of wonky. And then it's this intersection here. I'm going to connect those 2 dots, but I'm going to line up the compass, and do you see what else lines up, or my ruler, with those 2 dots? That corner. I want to draw this bisector where it's completely inside of the triangle. I don't want to go outside of the triangle. And then this is going to be point D. All right, the next side we do is BC, so that's this side, which means we need this intersection up here. Line it up with that, line it up with A. But draw that line and stay inside the triangle. And that's going to be point E. And then the last one is AC. So that center point again, and then hopefully yours fit on there. We're going to connect the dots, but stay inside the triangle. And that's going to be point F. We could have also bisected each angle, and they would have turned out the same way because it's an equilateral. So if you cut the angle in half, it's going to cut the opposite side in half. But that's just, again, that's an equilateral triangle because everything is equal. Other types of triangles don't work out that way, okay? But it's the rules like this is how we tell what kind of triangles we're dealing with if we're not given any information. Using these constructions, we can tell what type of triangle we've been given. All right, so the intersection points of D, E, and F are midpoints. Because remember, they're perpendicular bisectors, which means point D is the middle point between A and B. E is the midpoint between B and C. F is the midpoint between A and C. Now we've got pieces here. We've got some vocab coming up. And we'll talk more about these pieces, so don't panic on me. Altitude. So CD, this right here, that line that we drew. CD is the altitude of side AB. So knowing that information, can you come up with a definition of the altitude of a triangle? It's what? So it goes to the midpoint of that line and the opposite angle, right? Have we done altitude in our definitions yet? Altitude of a triangle, a line segment drawn from any vertex of a triangle perpendicular to the opposite side. We're going to do more with altitudes later. So this line is perpendicular. it goes through the midpoint of this side, and it goes through the opposite vertex. That's an altitude. This triangle, we've got 3 altitudes. You'll always have 3 altitudes because you've got 3 sides and 3 angles. So the next one is A to E. AE is the altitude of what side? BC. So it's where it hits. It's the side that it hits. And then finally, BF is the altitude of what side? AC. I'm not going to make you write all this down, but I'm going to show it to you. I should have printed this on there for you. Here's all the equivalencies. Okay? So MAD, M is the center of this thing. MAD, so this angle here is equal to MBD, this angle here. All of these equivalencies occur. And that's equal to MBE. MBE, that's equal to that angle. It's equal to MCE, it's equal to that angle. It's equal to MCF, that angle. And then MAF, MAF. So all of these little angles that are created, they're equivalent. The triangles that are made, so do you see all the new triangles that we made? Those are all equivalent as well. So on an equilateral triangle, when you draw the perpendicular bisectors, you make 6 equivalent little triangles. They're all exactly the same size. They have the exact same area, the exact same perimeter. Again, one of those little quirky things with geometry. All right, that's it for these crazy notes.